Hello! Today we're going to be taking a look and testing on my bench this quite interesting device. It is a power AC transfer switch. It is a direct copy of a Victron Energy one that is being called Filiax 2. And in my personal opinion, the genuine one from the Victron Energy is quite expensive. Basically, for the cost of transfer switch, you can get like a pretty decent Victron inverter. So I don't think it is being priced accordingly, but it is a very specific item, so maybe it is justifying the price. And here you've got the model number, just in case you'll be interested. You can purchase it on the Amazon. Let's take a look at the model number. Here you've got it, and we've got the instruction in German. So you are welcome to pause and take a look. We are going to be wiring it on my bench. As you can see, we can transfer 16 amp, which is exactly the same as on the genuine Victron one. And of course, it have to be like the capacitive load. For the inductive, like a motor, we are limited only to 500 volt amps. We can learn that we've got pretty low losses on this item, like below of 2 watt, which is very important if you are planning to use it with like a solar system. You definitely don't want to burn your energy into having like contactron energized. So yeah, 2 watt is totally acceptable. So let's make a visual inspection how this device looks. It is enclosed in plastic case. Looks like a hobby project, but the genuine Victron is exactly the same. The Victron one was like a gray one. Here we've got a black one. So I would not say that this is going to be an issue. We've got our grommets. We've got our specifications. And as you can see here, we've got a load. We've got the slave and we've got the master. Let's open this device and take a look what we've got inside. Let's take a look how to wire this device. On that terminal, we've got information that it is being called load. And basically, it is our 230 volt AC output. And here we are going to be attaching our end device, for example, a bulb. Then here we've got 2 input, and they are going to be bridged and directly connected to the load, depending on our logic. One is being called master, second is being called slave. Master we can think of a priority, and always when AC voltage is going to be available here, it will be connected directly to load. When the master is not going to be available, we are going to be bridging our load to the slave. If you are living in commercial environment and you've got 2 independent grid sources, like in a server farm, then your slave and master both can be grid, but most likely you are interested in using that system in like a off-grid solar installation. For that use case, your slave is going to be grid, and your priority master is going to be DC to AC inverter. So if you are generating electricity through solar system, then you are outputting here your 230 volt AC, and your load is going to be transferred to the solar system. When the sun is non-available, your load is going to be automatically transferred to the grid, and that's the main use case. But of course, it could be wire other way around. So imagine that you would like to have a backup battery system. So you've got your 12 volt battery, you've got DC to AC inverter, and you wire it into slave, and our master is going to be grid. And when the grid is going to be non-available, your load is going to be transferred back to your backup inverter. Let's take a look how our device is performing. So we need 2 power sources. And here we've got one goes 0, here we've got the second one. Let's begin our operation from wiring it. Let's stripe those 2 guys. Just like that. And we need a very nice terminals because we would like to have it looking professional. So we go like this. And we are pretending to be professional, so this is what we want. So let's take a look how to wire it. First, we are going to be connecting our master. PE is our protective earth, which is not used on this isolated system. Then we've got our live and neutral. I will use the correct color code, but it do not matter on this isolated system because it is not referenced to the ground. But I'm just mentioning it. So we are pretending to be professional. Just take a look how professionally. With our slave situation is exactly the same. The protective earth is not going to be connected. Then we've got our live and neutral. So I will follow the same color code. The brown is going to be our live. And the blue is going to be neutral, which do not make any difference on the isolated system. But let's pretend that we are professional and we are following the color code. So we go just like that. As you can see, absolutely beautiful. Now we have to think what connect to our load. And I will be using this LED indicator light that is presenting like this. Absolutely beautiful stuff. So we've got the same situation. We've got our live and neutral. So I will be following the correct color code. And the PE is not going to be connected. We go like this. So it is going to be quite interesting. Here we are putting our neutral. And I will go with the full brightness one. Most likely there is just a resistor. And here we put our live. So we go like this. Absolutely beautiful. We are ready to give it a try. On our master, we've got an inline switch. So we are plugging it in. On our slave, we do not have nothing. We're starting our inverter and we are powering it on. If everything is fine, as you can see, we've got our indicator glowing and our load is being powered from that goal 0. Then let's energize that one. It is our master and we should be transferred here. And let's wait. Nothing, but maybe the switch. And yes, we are being transferred to our primary and we can see that our power is being pulled here. So if we lose our master power, we should be transferred back to our goal 0. And if we recover from our power outage, we are being transferred here. There is one thing that is worrying me, that we've got this delay. Let's take a look at the user manual. And looks like we've got a 2 seconds transfer time. So I would say 1, 2, yeah, definitely in the specification, but forget about using this device to transfer like a computer because you will expect a power disruption. Definitely 2 seconds computer will not survive. So just for 1 second, let's imagine that this is your grid power supply. And as you can see, your load is working fine. You are paying for the electricity. But then your sun is rising, your solar inverter is starting working, and your load is going to be transferred to this device. And that one, even it is available, as you can see, it is not being used. We've got absolutely nothing here. then your sun goes down, or maybe the battery in your solar system go like a flat, and the inverter stop making electricity, and your load is being transferred back to the grid. The cycle repeat the other day around, and you are going to be transferring back. So absolutely beautiful. And in my personal opinion, for the price, it is much better than the genuine Victron energy. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.